Hi, I'd like to address Leetcode number 2373, largest local values in a matrix. So the question essentially wants you to have a method accept a grid. And then within that grid, what we want to do is we want to find the maximum value within a local area. So that local area in the bigger grid that was given to us, we can assume is a 3 by 3 grid. So perhaps we're looking at this area here. And in this 3 by 3 grid, we're essentially tasked with finding what the biggest value is and then putting that into a resultant 2-dimensional array of that 3 by 3 grid. And then we actually look at the next 3 by 3 grid that is valid. So the next 3 by 3 grid may start from here. And then we find out what the maximum might be from that section. And then we put that into our resultant. So for the first 3 by 3 grid, we can see that the maximum value within that local area is 9. And then for the next 3 by 3 grid, we notice that 9 is also the maximum value. We do this for the next 3 by 3 grid that can be formed, which would be this area here. And the maximum value we see is 8. And so 8 is put into the resultant. And then for the next 3 by 3 grid, we see that the maximum value is 6. And so that is then put into the resultant. So if we had, we can assume that these are values. So really what we're trying to do is we're trying to sort of section off 3 by 3 grids. And we would perform a set of operations that would allow us to find the maximum within that local neighborhood. So we can assume this is a 3 by 3 grid, and we can assume this is also a 3 by 3 grid. And then, of course, we would have another 3 by 3 grid here. And then, of course, another 3 by 3 grid here. So really what this comes down to is using a 2D array and then traversing through the 2D array in a manner that allows you to process the 3 by 3 grid from any particular point or from the point that we're on. So just so that we can get some review as far as 2D arrays are concerned, you can declare a 2-dimensional array using an extra bracket. So here, usually for a 1-dimensional array, you would actually just have one bracket, and then the other bracket would actually give you access to sort of a grid. And then you can declare your array, and of course, you'd have to use the 2 by 2 bracket again. Now, the first bracket actually gives you access to the rows. So you would put your row length in here. And then your second set of brackets gives you access to the column. So you'd actually put your column length in there. So let's say 3 by 4, let's say I had 3 rows and 4 columns. The total number of elements that can be contained within this 2-dimensional grid are 12 elements. Or you can find that out by multiplying 3 times 4, which is 12. Now, iterating through a 2-dimensional array is also very important. Many problems can be solved by 2-dimensional array traversals. So what we usually do is we open up a for loop for the length of the 2-dimensional array. And then we actually have a nested for loop. So the nested for loop is for each element within the 2-dimensional array. So we can imagine that we have that we've declared a 2-dimensional. So this is how you would formally declare a 2-dimensional array. It's not initialized, but we can actually initialize the 2-dimensional array as such. We'll say ARR2 is equal to, and then we can use these brackets, and then we can start populating the 2-dimensional array, which is actually just an array of arrays. So we can say that this has elements like this, and we can say that this has elements like this, and we're sort of just listing off the arrays within the overarching array. We can say this is 5 and 8. And then to close it off, we have a semicolon at the end. So this is a shorthand declaration of declaring a 2-dimensional array, or actually declaring and initializing a 2-dimensional array. The first method doesn't actually initialize the array, it just declares a 2-dimensional array with default values. However, so if you wanted to, we'll call this ARR2 for purposes of demonstration. So if you wanted to traverse this two-dimensional array, what you would do is you would take the outer for loop, and then the outer for loop is going to traverse through the array length. It's going to traverse through these elements, and then when you're looking at each particular element, which is an array, you want to traverse the length of that element. So you're going to introduce a j variable here inside the nested for loop, and you will actually be iterating through array of I dot length. So what this basically means is that for each particular row, you are essentially looking at like for each particular element in the two-dimensional array, you're accessing the element's length property. So the element in this particular example is an array, and each array has a length property or attribute associated with it. So you're accessing each element's length property to actually get inside these elements and sort of touch them row by row. And then you can, of course, perform, these are where, these are where your operations would be contained. And that sort of solidifies that. So for this problem, we actually follow this type of 2D array traversal. Actually, what it wants you to do is it wants you to declare the resultant array to have a row length of n-2, where n is the length of the grid, and then the column length is also n-2. So there's some mathematical relationship between where if you had, let's say, a 4x4 grid, then you could you're only going to get a maximum value from a local section. Or you could have four 3x3 grids, so one value from each. So you would actually generate a 2x2 grid, which is why we do n-2, n-2. So over here, I've declared the grid length as n for purposes of ease, and I've declared the array as n-2, n-2 for the row and column length. And then you want to actually begin populating the array, the resultant array. So over here, you open up an outer for loop that will actually iterate through the answer's length. And then you open up the inner for loop, and then you begin populating the elements of this answer. So what we can imagine is that so in our case, if we were given a 4x4 grid, then we essentially have a n-2 in terms of column and row, or row and column. And so that would look something like this, where we have a 2x2 row wise and 2x2 lengthwise, or column wise, 2 rows and 2 columns. And so the first point here, in terms of the indice, we can imagine that I would be equal to 0, and j would also be equal to 0. So this point here is the 0th column and the 0th row and 0th column. Naturally, you want to be able to say that, okay, it's the first row, it's the first column, and so that will be the location of that entity there. But then again, in the thing with the indices is that it's offset by 1. So the first would actually be denoted by 0 instead of 1. So you would actually say, okay, well, the first row is 0, is denoted by the 0th index, and the first column is denoted by the 0th index as well. So I is equal to 0, j is equal to 0 here. So we're populating this first top row, the 0th row, and that's why this outer for loop denotes the row that we're populating. Then inside, we're going to touch each column. So the outer for loop will take us to the row, and then inside, we're going to touch each individual column. So we have the for loop that will do that for us. So we're only going to iterate until there are available columns or answer of I dot length, which would in this case be 2. So we're going to iterate twice. And for the first time, I is going to be set to 0, j is going to be set to 0. And then what should we do? What value should we put at this particular location? Well, what we should put is we should create a helper method that will return to us the value, the maximum value contained within a 3x3 grid starting from the point 0, 0. So in our example here, this is the point that we have sent to the helper. So this is our answer, right? This is our answer. We have a 2x2 grid. So we can think of this as this here. We have sent the point 0, 0. So 0, 0 needs to be populated where the first 0 is I and the second 0 is j. We have sent this to a helper method. Now, this helper method is going to take the original grid. It is going to take the I, and it is going to take the j. And then the purpose of this helper method is essentially to look at the 3x3 grid starting from this original point and to find the maximum value contained within that 3x3 grid. So the definition for this helper method is going to be, okay, well, we will call it helper, and we will pass in, the parameter definition, or the method signature should be, a 2D array. We will call this grid because we are going to pass in the original grid. And then, like I said, we're going to pass in the indices, I and j. So we will call the I will be the row. So we will call this row. And then the other j denotes the column. So we will call it column. And what we're going to do is we're going to say, okay, well, I need to store. This helper method will be called for each individual box that we're trying to populate. So it will, in this case, it will be called 4 times. And so each time we need to calculate the maximum within a 3x3 grid starting from the point that was passed in. So int max will denote what the maximum is. We will set this to 0, or you can set it to integer.min value in Java. And then we will open up a for loop where we will say, okay, I is going to essentially represent the row. And what we're going to do here is we're going to say I is less than row plus 3. So I is less than row plus 3, I plus plus. We will talk about why I have said row plus 3. So why have I said I is less than row plus 3? Well, I know that for each individual index that is passed in, each point that is passed in, I only want to process 3 rows and 3 columns from that point. So the minute I pass in this point, which will be 0, 0th row, first column, I would essentially want to only process 3 rows and 3 columns starting from the original point that I have passed in. So if I is 0, we will say for the first point, let's say this point here, I is 0, j is also 0. So I is less than row plus 3. What was the value of row? The value of row was 0. So I is less than 3. So that means int I is equal to 0, I is less than 3, I plus plus. We are only going to process 3 rows. However, a rational question might be, what if this was 1? If this was 1, then I is equal to 1. I is less than 1 plus 3, which is 4. So I is less than 4. Now, you might say that we don't want to process 4 rows. Well, the idea here is that because I have said I is equal to row, whatever the value of row is, I add 3 to that. So between 1 and 4, there's always going to be maintained a gap of 3. So if I pass in any value here, such as 88, or we can say 80, I will be row plus 3. I will be less than the row, which was 80, plus 3, which is 83. So I is equal to 80, I is less than 83. So I am always maintaining a gap of 3. So this is important. So for whichever row they pass in, I will say I is less than row plus 3 because I want there to be a 3 gap maintained. I only want the rows to be processed 3 times. And the same treatment can be applied for the columns. So int j is equal to the column that was passed in by the method call. And then I will say I is less than column plus 3, I plus plus, or j plus plus. So these should be j. Okay. So if the column, let's say, is 1, then I will say j is less than column plus 3, which would mean that j would be less than 1 plus 3, which is 4. So I have I is equal to 1, j is less than 4, the gap of maintained is 3. If so, you can imagine if I, let's say, passed in the point 1 comma 1, here I would have I is equal to 1, I is less than I is less than 4, so I maintain the gap of 3. Same here, in j is equal to the column, the first column, and then column plus 3, I get 4. Again, I maintain the gap of 3. Even if I, let's say, pass in 2, I pass in 2 for the column, 2 for the row. That would give me 3 plus 2, which is 5. So I'm maintaining the gap of 3, right? 5 and 2. Same treatment applied to the column. And the logic that I want to essentially have here within, so where the actual elements of the matrix actually is accessible to us within the inner for loop. So in here, I will just basically say max is equal to math.max. Either it will be the max, like either the max will be what the max was before, or it will be the new element, grid of j, grid of I, comma j. This is going to give us access to the element that we're looking at. And then ultimately, we are going to return whatever the maximum was as we process 3 rows and 3 columns. So this is exactly what we've done here. We have created we've stored n in memory for the grid length, created the answer, and then we've actually iterated through the answers. We're going to look at the rows first. So the first row, and then we look at, okay, what should I put at the first row, first column? Well, answer of first row, first column should be a call to the helper, which will process a 3x3 grid and give you the maximum of the 3x3 grid. So the first row, first column will store the maximum of the first 3x3 grid. So that would be 0, 0. Then as we process 0, comma 1, from that point, from 0, 1, we branch out from 0, 1, and we process the 3x3 grid. We return the maximum. Then we would move on to the next row, and so we're on the next row. We're at the 0th row. So it would essentially be, you can imagine if we're here, we're at 0, 0, then 0, 1 in the answer, and then down here we're in the 0th row, second row. So that would be 1, 0. And then when we're at 1, 0, we would process again a 3x3 matrix and then find the maximum value and return that to the original call. And then as we do this progressively, each of the elements within our answer array are populated with the maximum value within their own